Hi, this is Mrs. Carnes. This video is going to be on graphing linear inequalities. There's a couple of things that we need to remember again. Here's that word linear. Linear means that it's always going to be the graph of a line, so we know that all of these inequalities are still going to be lines on our coordinate plane. We also need to remember what inequalities are. We have less than, greater than, less than or equal to, and greater than or equal to. Now, when we graphed these inequalities on number lines, we were able to show that the less than and the greater than were always going to be an open circle on your number line, and the less than or equal to and the greater than or equal to were always going to be a closed or basically a filled in circle on your number line. Well, we're not going to be graphing on number lines right now. We're going to be graphing linear inequalities. They're going to be on coordinate planes. And so we have to distinguish between these symbols using our lines. So anytime you use a less than or a greater than symbol, that is going to produce a dashed line on your coordinate plane. And anytime you're dealing with a less than or equal to or a greater than or equal to, you will always graph that as a solid line on the coordinate plane. So let's go ahead and take a look at an example. If I wanted to graph the equation 3x minus 5y is less than or equal to 10, very first thing that I have to do is I have to get this equation into slope-intercept form. That's the easiest form for me to graph in. Right now, you'll remember that this is in standard form. Standard form says ax plus by is equal to c. We know that this is standard form, but it's a little more difficult to graph in this form. If we were left in this form, we could find intercepts and plot those intercepts, the x and y intercepts on our coordinate plane, and then graph that. But let's go ahead and take a look at how would we convert the standard form into slope-intercept form. To do that, again, we want to get the y by itself. We want to move everything else away from the y. So the very first thing I would do is I would subtract 3x from both sides of my equation. I will end up with negative 5y is still less than or equal to negative 3x plus 10. Remember, you cannot combine these because they are not like terms. So we just list both of them separately. Now I have to get rid of that negative 5. Since it's being multiplied to my y, I know that I have to divide. So I divide by negative 5 on everything. All terms get divided by negative 5. Now, if you remember, we're dealing with inequalities. When we divide or multiply by a negative number, we have to flip our inequality symbol here. So we are dividing by a negative. So we know bells and whistles are going off telling us we have to make sure that we change that sign. I'm going to go ahead and change it right now so I don't forget to do that. It now becomes a greater than or equal to sign. These disappear, leaving me with just a 1, or we could write it as y. This negative over a negative becomes a positive, so I end up with a 3/5 x. And then positive 10 divided by negative 5 is a negative 2, or a minus 2. Now when we take a look at this, we were trying to get this form into y equals mx plus b. And let's just write it underneath, y equals mx plus b. We can clearly see that we have taken an equation that was written, or an inequality rather, that was written in standard form, and we turned it into an inequality that was written in slope-intercept form. Let's move on to step number 2. In step 2, you have to identify what your slope and your y-intercept is. This is something normal. When we were in slope-intercept form before, we were always identifying our slope and our y-intercept. We will then plot those things on our coordinate plane. So the very first thing we're going to look at here is I'm going to rewrite our y equals mx plus b form so that we can see that our our m ends up being 1/2. And our b ends up being not or not positive 2 because these are opposite. So it actually is going to end up being that negative 2 that we're going to look at. And so I'm going to list my slope as 1/2. Remember 1, that's positive up, 2, positive to the right when we affect our slope. And our y-intercept is negative 2. And so we would always graph our y-intercept first. So I plot negative 2 on my y-axis since it's a y-intercept. That'll give me this point here. And from this point, I affect my slope, which is to go up 1 over 2, which would give me this point here. I could continue to go up 1 over 2 again and get a few more points, and they would be this point and this point. This point. I could also go down 1 to the left 2 and give me that point. Now notice, we're not connecting these points yet. That's going to happen in step 3. In step 3, we have to decide if the line is going to be a dashed or a solid line. So we already know that our y-intercept was here at negative 2. We also know that we went up 1 over 2. We already did the slope. And these points indicate that on our line. We have those points. And now we have to decide, is it a dashed line or a solid line? Since this is the symbol that we're dealing with, since we're dealing with a greater than or equal to symbol, we know that we're going to have a solid line on our graph. So I can now connect all of my points with a solid line. And then the second thing we have to do is we have to shade the appropriate side of the line. If we go back and we look at just this first part of our equation, the y and the inequality, I'm going to rewrite that. That is y is greater than or equal to. It says y is greater than or equal to. Anytime you have a greater than or equal to, or even just a greater than sign, you're going to shade above the line. And so if I look at this line here, I want to shade above it. So that's going to be anything that's going to be in this direction. So I'll take my pencil and I will shade all of this information or all of these points that are above the solid line that I graphed. Now that's what your graph would look like. You could leave it like this. It was a solid line. You shaded above the line, which is going to be appropriate. But let's take a look at what this really means in terms of solutions. So here we have our same graph. We have our solid line and it's shaded above that line. Now let's talk about a solution. The solution to this inequality is any point that lies in that shaded area. So it could be this point could be a solution, or this point is a solution. The origin, 0, 0, would be a solution, or this point could be a solution. This point even would be a solution here. So there's lots and lots of points that you're going to have. In fact, there's going to be an infinite number of solutions. The important thing, though, to look at is this solid line. Since it's a solid line, any point that lies on the line is also considered a solution. So this point would be a solution to your inequality. This point would be a solution to your inequality. Any point that lies on that line is also going to be a solution. Now just make a point here. If this line would have been a dashed line, then these points in the shaded area would be solutions, but any point that was to lie on the dashed line would not be a solution. So you have to keep that in mind. So let's just list a few of the solutions. I could say the point 3, 4 is a solution to this inequality. Or I could say the point -5, 0 is a solution to this inequality. I could also say the point 4, 0 is a solution. 4, 0 lies on the line, but since it's a solid line, that would work. So now you know how to graph inequalities. First step, make sure it gets into standard form. Second step, find your slope and your y-intercept, plot them on your graph. And the third step is to decide if it's a dashed or solid line, and then decide which side of the line you need to shade on.